In this video, we are going to talk about the basics of ordinary differential equations. Now, on the board, I have put a series of questions, 10 questions, in which we are going to analyze and study the basics. Okay, now you notice the question says classify each of the following differential equations as to whether they are ordinary or partial, okay, linear or non-linear, as well as unknown function and independent variable. Now, this might be your first time studying these aspects of calculus, differential equations. So first of all, you might want to ask yourself, what is a differential equation? It is very simple and there is no basic definition to it, okay? All you have to do is understand the concept of what differential equations talk about, okay? Now, when we say a differential equation, it simply means a function that have been differentiated and then rearranged into an equation, okay? So let's say we are having the function y is equal to kx squared, and then I choose to find the derivative of this function. dy over dx then becomes 2kx, isn't it? Now if I choose to rearrange this guy and form an equation, I'm going to get dy is equal to 2kx times dx. I could as well bring it to this side to give us dy minus 2kx dx is equal to 0. This is an equation as well as this one, okay? Anyone could be used. Now what we're having here in this case is what? A differential equation, okay? And then there are different ways to classify several differential equations, and this will help us apply solutions, okay? What are the solutions? That is, if we are given this differential equation, it could be asked to solve it back and get the question. So the aim of every differential equation you find in any material or textbook is to simply solve the differentiated function or the final answer and get back the question, okay? So it's simply like integrating, okay? That is why in differential equation we make use of what now? Integration. So if you are not used to the concept of integration, I'll ask you to at least study some of our videos that we've talked about integration, the basic concepts, and then they will help you understand how to solve problems on differential equation. But in this case, I'm just having a table of which I'll be classifying under A, ordinary or partial differential equations, linear or non-linear equations under B, and then for C, we are going to have unknown functions. D, we are going to have independent variable, and then we're going to have as well the order and the degree, okay? So I'm going to include it. For E, we are going to have the order of the differential equation, and for F, we are going to have the degree. Now, let's proceed to tackling these problems and also the explanations on ordinary, partial, linear differential equation, as well as the other ones you are seeing on the board. Now, the first question we're having here is s double prime minus 4s prime plus 5s equals cos x minus 4 sine x. That's the first question we're having here. Now, what you notice in this first question, the differential equation, it is put in a different form such that you cannot even locate the s over the x or the y over the x in this case, okay? But you can see that since s is carrying the prime on top, it simply means that s is being differentiated with respect to every other variable we're having here, which in this case is just x, okay? So s is being differentiated with respect to x. So I could as well rearrange this equation 1, or question 1 rather. I could as well arrange it and rewrite it in the form d2s over the x squared. Because we're having a double prime, simply means we're what now? Differentiating twice. That is why we're having a 2 on top and a 2 under as well, okay? Minus 4s prime minus 4s prime simply means ds over the x, okay? It's carrying 1 prime because we are differentiating just 1, and this one we're differentiating what now? Twice. And then plus 5s, okay, which then equals cos x minus 4 sine x. It then equals cos x minus 4 sine x, okay? So this is the form we want to put the differential equation, okay? That's the form we want to write it in. I think it will at least be better to put it in that form, which is the general form, rather than in this notation, okay? As that will help you understand the concept better, except of course you get used to it. Now, how are we going to know if that differential equation on the board is ordinary or if it is partial? First things first, what is a partial differential equation? That's what you want to ask yourself, okay? A partial differential equation is a differential equation that has been formed due to the partial derivative that is taken of a function. Now, what is partial differential equation? Okay, a partial differential equation is simply a differential equation that is formed from the partial derivative that is taken from a what now? A function. Now, whenever you see this notation, let's say dy over the x, written like this simply means what now? The function has been differentiated partially. Another way it could be written could be ux double x. Okay, once you see u double x, simply means this one has been differentiated twice partially. Okay, now when you see uxy as well, it means it has been differentiated what now? Twice partially. But when you see a single one, just it simply means we're having what now? Partial derivative of u with respect to x, which is partial derivative of u with respect to x. And for this one, we're having partial derivative of u with respect to x, since x is coming first, and then with respect to y. So this is second derivative, this is first derivative. So whenever you encounter this symbol or letters and subscripts like this, it simply means they are what now? Partial derivatives. Okay, and if you find them in any equation at all, what are we going to pick that equation as? A partial differential what now? Equation. So whenever you have these things, we are going to call them partial differential equation. So the differential equation, I'm going to abbreviate it as DE. Okay, so you know what it means. Now, how about the ordinary differential equation, which is going to be the base or the basics of what we are going to talk about in our next video as well? Okay, ordinary differential equation. Now take note, for an ordinary differential equation, or for an equation to be ordinary differential, okay, it needs to have any of these in the equation. It needs to have dy over dx, okay, the 2y over the x squared, the 3y over the x cubed, and so on and so forth down to the ny over the x to the power of n. So whenever you find any of these guys in an equation, as well as the dependent and independent variable, which is x and y, this is the dependent, and this is the dependent, and this is the independent. Okay, I'll talk about the dependent and the independent variable when we get to this one, which is option C and D. Okay, I'm going to talk about that. But now take note that if you find a differential equation that has these guys, okay, that has these guys, dy over dx, the 2y over dx squared, and so on and so forth, and also x and y in the equation, forming the equation only, what are we going to call it? We are going to call it an ordinary differential equation. Otherwise, we will find something like this symbol used as the derivative, and as well as these guys. So if you find this one, what are we going to call it? We'll call it what now? Partial differential equation. So I'm going to come to these questions and then analyze. So for the first one, we are not having any symbol like this. This is in fact a short trick. Check if it is partial. If it is not partial, automatically it is what now? Ordinary. So now check. For this first question, we cannot find any symbol like this. Okay, there is no such symbol like this derivative or u with a subscript of x in this first question. Okay, since you cannot find it, it means it is what now? Ordinary. So I'll come here and I'll say this one is what now? Ordinary. Okay, ordinary differential equation. Now how about 2? I still can't find that symbol. Neither can I find u with a subscript of x and y. It means option question 2 is also ordinary as well. Okay, and then for question 3, we can find u with a subscript of x. The symbol is not there, but we can find u with a subscript of x. This one defines the explanation I gave as to whether an equation is partial. Okay, for that reason, number 3, we are going to call it a partial differential equation. What about number 4? For number 4, we cannot find this symbol. Neither can we find u with a subscript of x. So what am I going to call number 4? Ordinary. Okay, so number 4 is an ordinary differential equation. Now how about number 5? For number 5, we can say that we cannot find the symbol again, this partial derivative symbol. Okay, neither can we find u with the subscript of x. Okay, so if you check for number 5, we can't find it here. So automatically it is what now? An ordinary differential equation. You notice that we're having the I over the t. Take note, it is not only dy over dx, the 2 over dx squared we can have. Okay, we could as well have other letters, for example the p over the k, the y over the t, and so on and so forth, provided it is just what now? 2 symbols following this what now? This format. So for number 5, we are going to call it what now? An ordinary differential equation as well. Now how about number 6? For number 6, this is similar to number 1. You just have to put it in the general form, which is the 2q over the x squared, okay, which is which tells us that q is being differentiated with respect to x, okay, plus the q over the x minus 2q equals 3 exponential x. Okay, so in this case, we notice that we cannot find the symbol there, neither can we find u and the subscript. So we're going to call number 6 what? An ordinary differential equation. Okay, how about number 7? For number 7, we're having the partial derivative symbols as well. Okay, you notice that there is a partial derivative, the second partial derivative of k with respect to x, and then to y. Okay, so obviously number 7 is the what now? A partial differential equation. So I'll come here and then I'll write partial differential equation for this one. And then for number 8, we are having the same format as ordinary differential equation. So I'll come here. Number 8 is what? Ordinary. Okay, so it's quite easy. And then for number 9, which is the next one, this one does not have the symbol, neither does it have the subscripts and the derivative. Okay, so number 9 is what now? Still ordinary. And then for number 10, we're having y double prime. Y double prime is the same thing as dy over dx. Okay, so nothing is changing. So number 10 is also what now? Ordinary differential equation. So you notice that only number 3 and number 7 are partial differential equation, and they are very easy to identify. Now a shortcut or a short method that I just explained is simply to check if it is partial. If it is not partial, we pick it as what now? An ordinary differential equation. That is the quickest way you can use. Okay, so whenever you don't see these symbols or the differential equation is not written in this form, then we know that it is what now? Ordinary. If it is written in that form, it means it is what now? Partial. And then for the next question, so we are done with A. We are done with A. For the next one, we want to check if these equations as well, if they are linear or non-linear. Now, when something is linear, what does it mean? Simply means it goes smoothly, right? There is a short trick or a shortcut that we can use to check if a differential equation is linear or non-linear. Now, we are having these derivatives here, okay? These derivatives. Take note that whenever these derivatives, they are having an external bracket and a power on top of that external bracket, we are going to take it as non-linear. I'll repeat, whenever a differential equation or these differential equations, dy over dx, the 2y over dx squared, they are having an external bracket, and that bracket is having a power. We call it what now? Non-linear. That is the short trick. Okay, you can as well look up other definitions for a non-linear and linear definition, differential equation definitions. Okay, now like I said, whenever we are having these guys and they are having a power attached to them, we call them what now? Non-linear. Now, not just them, these variables as well, the independent and independent variable, whenever they are having powers as well, we also call them non-linear. Okay, so otherwise they become what now? Linear. Just the same way we use this definition in identifying an ordinary differential equation. So if it is not partial, definitely it is what now? Ordinary. Now I'm going to make use of some examples to answer the definition or to simplify the definition that I just gave, or the shortcut to ask whether an equation is linear or non-linear. Now for number 1, we're having s double prime minus 4s prime plus 5s and so on and so forth. You notice that this is the s over the x, this is the s, this is the 2x over the x squared, this is the s over the x. Now you notice that none of these are having an external power. That is, there's no bracket here carrying the power. Okay, neither is x carrying what now? A power as well. Assuming these ones are not carrying powers, but these ones are carrying powers. Okay, it will still be what now? Non-linear. That is the trick. Okay, you just have to practice or go with me through these examples to understand the concept I'm talking about. Okay, so for number 1, it is what? It is linear. Okay, simply means it is not, none of the derivative of x is having a what now? A power. Okay, and then for number 2, you notice number 2, there is an external bracket and then there is a power 4 over 3, and this one is having 2. So you notice that the derivative, they are having what now? An external bracket and a power. External bracket and a power. For that reason, we pick them to be what now? Non-linear. Okay, so for this one, I'm going to come here and then I'll say it is non-linear. That is the trick. Okay, and then for number 3, is it linear or non-linear? Now you notice there is no power as well, like I explained. Okay, this one is simply the 2u over the x squared. Okay, in partial form, that is simple we're going to use. And then this is the 2u over the x dy. Okay, in partial form. And this one is the 2u over the x dy as well. Okay, I think this should be dy. Okay, this should be double y, not xy, because if it was xy, these two would have just subtracted each other. Okay, so this is the correct form. Now when you expand it and you write it in this format, of which I'm going to bring out here, okay, that's number 3 is partial derivative of second partial derivative of u with respect to what now, x, plus second partial derivative of u with respect to x and then y, okay, minus 2 times the second partial derivative of u with respect to y. Okay, that is what we're having there. So that is number 3 expanded or written in the correct form. Okay, so that is that for that. You notice that none of these are having a bracket and an external power. For that reason, since they are not having it, we are going to call number 3 a linear differential equation. So we are going to call this a linear differential equation as well. Okay, and then for number 4, here is the case. Notice that the y does not have an external bracket, neither does the x have an external bracket. Also, x and y, they do not have an external bracket or a power. But you notice that there is y squared and then there is x squared inside of the bracket. Because of this square that is affecting this dependent and non-dependent variable, which I have not explained yet, okay, x and y. Because of this square that is affecting it, this number 4 is going to be what now? Non-linear. Because there is a bracket and there is a power affecting it, right? So number 4, we are going to call it a non-linear differential equation. How about number 5? For number 5, notice that there is no external brackets or a power affecting any of the differential equation or the dependent or non or independent variable. Okay, so for number 5, it is simply what now? A linear differential equation. And then for number 6, this one is straightforward. You can expand it in the form again, which is dq over the 2q over the x squared plus dq over the x, okay, minus 2q equals to exponential x. Okay, notice that this one does not have any external bracket and the power. So for number 6, I'm going to call it what now? A linear differential equation. How about number 7? No external bracket and the power. So for number 7, I'm going to call it a linear differential equation. And then for number 8, this one is having an external power, 1 over 3 here, affecting dv over dx. Okay, because of this guy, we are going to call number 8 a non-linear. Okay, it is non-linear. So that is the short trick. And then for number 9, we're having external powers, so we're going to call them non-linear. Okay, non-linear differential equations. And then for number 10, this one doesn't have, so we're going to call it what now? A linear differential equation. So that is the short trick. You might want to rewind the video and go over the explanations I just made to as you determine if it is linear or non-linear, and to give you a clearer understanding on it. Okay, or you can watch the video over and over again, as practice makes perfect. Okay, so we are done with B, and then what is next is the unknown function. Now take note that the unknown function simply means the dependent variable. I'm going to write it here. Unknown function, okay, means dependent variable. Okay, what does that tell us? It means option C is the opposite of option D, as unknown function means dependent variable, while option D means what now? Independent variable. Now, I've been making use of these two words, independent and dependent, in terms of these ordinary differential equations and partial as well. But how do we know the unknown function, or how do we know the dependent variable, and how do we know the independent variable? Now, to identify the dependent variable is usually the one on top of the differential equation. And the dependent variable, in real sense, simply means the variable that its value is going to change depending on what the other value brings in. So if, for example, we're having y is equal to f into brackets x comma y, okay, or let's say x comma k rather, y is the dependent variable. Why is y the dependent variable? Because y will depend on any value that x or k takes. Okay, that is what it means. Okay, y is going to depend on any value that x or what now k takes. So for that reason, y is the dependent variable, and x and k are the what now? Independent variable. Now you should take note that this example I just gave here is what we call a partial differential equation. A partial differential equation is also a differential equation that involves more than two variables, or two or more variables rather. Okay, if it involves two or more variables, then we call it what now? A partial differential equation. You notice that for these ones, we're having ux, okay, and y, okay, in these examples. So since it involves more than two, rather, it involves more than two what now? Variables. We call it what now? Partial differential equation. Take note, more than two, okay? If it is equal to 2, it is usually what now? Ordinary, and every other value or alphabet you find there most times acts like a constant, okay? But if it is what now? More than 2, we call it what now? A partial differential equation. So that is also another method you can use in analyzing equations or questions to see if they are what now? Partial. The reason why it is not encompassing is because imagine you are having p dy over dx plus yx equal to 0. We're having p, y, and x, but you cannot call this a partial differential equation. This is simply because this guy is not being differentiated partially, okay? So that's the mistake most people make. That was why I had to what now? Skip the definition to that initially, okay? Now, for C, we're talking about the unknown function. I said the unknown function is the dependent variable, and it is usually the one on top. So in this case, we're having dy over dx equals 2kx. Y is the value on top of the derivative. In this case, u is the value on top of the derivative. So the value on top of the derivative is usually the what now? The dependent variable. Okay? Now, for these examples that are here, let's go through them and tell which of them is the what now? Dependent variable or the unknown function. So for one, when you expand this is ds over dx. S is the one on top. So this is what now? The unknown function. And then for 2, y is the one on top, unknown function. And then for 3, u, okay, is the one on top, so it's the unknown function. For number 4, we're having y as the unknown function. Number 5, we're having I as the unknown function. Number 6, we have q as the unknown function. Number 7, we have k as the unknown function. Number 8, we have v as the unknown function. Number 9, we have y as the unknown function. And then for number 10, we have y as well as the unknown function. Now what you notice is that when you look at these questions, okay, for example number 10, you might not see it directly. What you might need to do first of all is break it down. That is, you write y double prime as d2y over dx squared, okay, which is correct expansion to this when you substitute y double prime, okay. So that way you cannot see what is on top, okay, or you can simply say the value that's carrying the prime is what now? Unknown function or dependent variable. Now take note that the unknown function or dependent variable sometimes it can actually change, okay, depending on the way the equation is given to you. So I won't be wrong if I come to question 4 and I tell you that the unknown function is x and not y, because if I divide both sides by dx, I'll get dy over dx. Y is the one on top, so y is the unknown function. But what if I choose to divide both sides by dy instead? I'll get dx over dy. X is the one on top. So in this case, I'll say that what now? X is the what now? Unknown function. So that I could as well come to number 4 and I'll write or x as the unknown function. Same thing applies to what now? The independent variable. The independent variable is the opposite, okay? The one that is under the equation. So if I come to this same number 4 and I choose to divide both sides by what now? Dy instead. I could as well have x or y as the what now? As the what now? Unknown function, okay? But I'm simply just going to pick one so for simplicity's sake, okay? This is just basics. Okay, so for D, I'm going to come here and locate the what now? The independent variable. So if y is the dependent variable or unknown function rather, then it cannot be the independent variable. It automatically becomes what now? The other one, which is x. So, okay, for number 1 instead. For number 1, we're having x. Okay, so for number 2, we're having x as well. For number 3, this could be x or y. Okay, this could be x or y because u depends on both x and y. That is what we're having in this case, x and k. Okay, so we can as well write x or what now? Y. And then for number 4, since we already pick y as the dependent variable, x then becomes the independent variable. Okay, x. And then for number 5, we're having what now? I with respect to t. Okay, we already picked I, of which I is the only one. And then t becomes what now? The independent variable. And then for q, we have x. And then for k here, we have what now? X and y again. Okay, x and y again. And then for number 8, we are having x at the bottom, so x is the independent. And then for number 9, we're having x at the bottom as well. X is the independent. For number 10, we're having what now? X as the independent, because x is at the what now? At the bottom. When you expand, this is the 2y over the x squared. Okay, so it is that easy. Now the next thing we're going to talk about is the order and the degree of a differential equation. What is the order of a differential equation? Now the order did not really change in mathematics and algebra. Okay, when you are finding order of a quadratic equation, it is the highest power, that is the order. Okay, but for a differential equation, it is just a slight difference, it don't really change. Okay, for a differential equation, what then becomes the order? The order of the differential equation is now the highest power derivative. Okay, and it is usually between d and y. Okay, so for the order, it is the highest number that is between d and y. Now come to this example. Okay, we're having the 2y over dx squared, we're having the y over dx squared. The number between d and y here is 2. The number between d and y here is an invisible 1. Right? Which one is bigger? This one is bigger, right? So the order of the differential of this differential equation, question 2, is what now? 2. I'm just going to write it here before I forget. So for question 2, the order is what now? 2. Now how about this one? By expanding number 1, we get what now? This equation here. Now check between these two. Which one has the highest number between d and s in this case? It is what now? This one. So the order is what now? 2. So I'm also going to come here and write 2. Now how about number 3? When you come to number 3, you notice that the order is also 2 because number 3 can be expanded to this guy. Between this d and u, okay? Of which all of them are actually having the same. So in this case, we're having what now? 2. So the highest power of the derivative is always the what now? Order. So if, for example, we're having the y over dx, the 2y over dx squared, the 3y over dx squared, the one with the highest power of which, in this case, it is what now? 3 becomes what now? The order. Okay? I really don't think there's an example. Okay, there are examples here. For example, number 9. We notice that we're having the cube y over dx squared, and having the 2y over dx squared. Because the cube y is bigger in power, that is the number between d and y is bigger, 3 becomes what now? The order differential equation. And in this case, we call it what now? The third order. So if we're having 2 as the order, it's what now? Second order. 4, fourth order. 1, okay? And for 1, we don't usually write anything on top, it's just the y over dx, okay? For those cases, we call it what now? First order differential equations. So for number 9, the order is what now? 3. Now let's check for the other ones. So for number 4, what is the power between d and y? In this case, when you divide both sides by dx, I'll get the y over dx. So the power between d and y is what now? Just 1. Okay? Okay? Between d and y is just 1. So for number 4, the order is what now? 1. And then for number 5, the order is what now? 2. Okay? And then for number 6, when you expand this, you get the 2q over the x squared. So the order is what now? 2 as well. And then for number 7, this is also 2. And then for number 8, we have 2 again. And then for number 9, we've done it 3. And then for number 10, we have what now? 2. Those are the highest powers between d and y, or the derivative, anyone that is given. In this case, we have between d and v. So the highest power is what now? 2. There is 1 here, so 2 is higher. Okay? Now, that is that for order. So we are done with unknown function, independent variable, and as well as what now? Order. The next one we're going to talk about is degree. Now, for you to understand degree, you must first understand the order. That is why it is important for you to make sure you understand order in this particular video before you proceed to learning degree. At least you can give the video a rewind so that you can understand the order by watching it again and practicing more questions on your materials or textbook. That will help you understand the order, and then we'll move on to what now? Degree. Okay, so for the degree is going to depend on the order. Now take note, the degree of a differential equation is the external bracket. Remember we talked about external bracket before. It's the external bracket and the power on top of that external bracket. Okay, after all fractional powers have been cleared, that is what it means. So for you to identify the degree of a differential equation, okay, we need to what now? Clear all fractional powers. We clear all fractional powers, and then we go to where we have the order. Okay, so I'm going to take it as a step. So to identify the degree of a differential equation, first things first, these are the steps. We are going to clear fractional powers. Okay, so we're going to clear fractional powers. That's the first step. Okay, number 2, we identify where the order is. Okay, I'm going to make use of an example. For example, we're having question 2. We're having question 2 like this. Okay, in this question 2, we're having a fractional power. First, before you even start to find the degree, clear the fractional power. So to clear this fractional power, that is, remove the fraction. I'm going to multiply by multiply both powers on both sides by a number that will convert it into a whole number. So if I multiply both sides by 3, 3 cancels 3, we are left with 4. 3 times 2, that's 6. So we're having 6 here and we're having 4 here. Okay, so we've succeeded in removing what now? The fractional power. So I'm going to write the equation out and see what we're going to get. So after clearing fractional power, we get 1 plus the 2y over the x squared, okay, always to the power of 4 equals p into bracket dy over dx, always to the power of what now? 6. Okay, we've cleared fractional power. That's step 1. Now step 2, what is the order of the differential equation? Remember, the order of the differential equation is 2, and this was where we had 2. Okay, now this is the order, not the degree. We want to identify degree. To identify the degree, what is the power that is outside of the bracket of the one having the order? Here is the order. I did not check it, I chose to check it. Why? Because it is in this bracket that we're having the order. And what is the power outside, or the external power? It is what now? 4. For that reason, the degree of this question 2 is what now? 4. We can say it has what now? A degree to the what now? First power. That is what this means. Remember to clear fractional power, identify the order, and pick the number you're having inside the bracket as the exponents for the degree. Okay? So for number 1, when you do the same, this is number 1. This is what you get for number 1. Okay? In this case, there's no fractional power. Okay, no fractional power. We'll go to the order. Step 2. This is what now? The order. What is the external power here? 1. Divisible 1. So here the order is the degree order is what now? 1. And then for number 3, I've cleaned the explanation, the expansion. You can do that as well. For number 3, we notice that the order could be any of it, and then we pick the what now? The degree as 1, because there is no power outside of the brackets. Okay. And then for number 4, notice for number 4, we just have dy over dx. We have 1, 1. Okay, nothing is changing. For number 5, this is the what now? The order. There is no fractional power. Outside of the bracket, there is an invisible 1. Okay, so we have a degree of what now? 1. And then for number 6, we're having the same thing again. We have a degree of 1. And then for number 7, no external power. So we have a degree of what now? 1. Okay, and then for number 8, here is the what now? Order. There is a fractional power here. So to clear this fractional power, I know that I have to raise both sides to a cube. Okay, so I'll raise this both sides to the power of 3, raise both sides to the power of 3. You don't have to expand it, you just have to use the common sense. Okay, because expanding is very, very tedious. You don't have to expand. Okay, just a common sense will do it. Okay, so how we'll expand it, we know that 3 is going to clear this one to make it what now? 1. Okay, and then the 3 is going to affect the 2b over the x squared, where we have the order. So in this case, what becomes the degree of this differential equation? Number 8. The degree becomes what now? 3. Simply because of these fractional powers. Okay, so in this case, we're having what now? 3. And then for number 9, when you check for it, there's no fractional power, no need of clearing any fractional power. We just identify the order, which is the cube y over the x squared. After identifying it, what is the power outside of the bracket? We have what now? 4. Okay, so since this is the order, and the number outside of the bracket, which is the power, not just outside the bracket, it has to be a power. So in this case, we have what now? 4. So for number 9, the degree is what now? 4. Okay, to the 4th degree. And then for number 10, this is just the order here, the 2y over the x squared. There is no external bracket or power. So the what now? Degree is what now? 1. Okay, so there you have it. How you can differentiate or identify ordinary, partial, linear, non-linear, unknown, dependent, independent, order, and degree of a differential equation. Okay, everything has been explained here. So what you might want to do is practice small exercises. Okay, go to textbooks or materials and solve questions or problems that are asking you to identify any of these. Okay, or figure these things out, as these ones or this video will give you the basic to any of those problems. Trust me, if you can watch this video over and over again, I think it's twice, you should get a proper understanding on how to identify all of these. Now, in our next video, we'll be talking about the other aspects of differential equations, how to solve differential equations, the various methods we have: homogeneous, inhomogeneous, variable, separable, and the likes. Okay, we're going to talk about all of that. So do worry to leave a like, okay, and drop a comment in the comment section if you have a question you need to ask. And also, if you have a video in mind you want us to talk about, drop it in the comment section, and then I'll consider it based on the amount of persons that are requesting for that particular video. Okay, also do well to click on the notification bell so that you get notified when a new video is being uploaded, as you might want to learn more. Okay, and don't forget to share with your friends. Don't learn alone. Okay, share with your friends. When you share with your friends, they're happy with you, they tend to share more videos that we've created to you guys as well. Okay, when you are not being notified about it, probably you forgot to click on the notification bell, of which that is why it's very, very important to do that now. Okay, also do well to subscribe, smash that subscribe button. Okay, and the YouTube channel name remains Dr. Flash. See you in the next video. God bless.